Circles. Standard form. As long as it fits perfectly in this form, life is good. Is it going to always fit perfectly in this form? No. But in homework, does it fit in this nice form? Yeah. Which is good, because it's only section 1.2. We're starting easy, right? But what does this form represent? Help me out. HK, always, always, whether parabolas or whether circles, stands for a very important point. What's the very important point for a circle? Center. So you can go ahead and say, all right, if it's in this form, or if I can get it to look like this form, HK is going to be, for a parabola, it's vertex, but for a circle, it's center. And technically, just because we're honors, H represents a horizontal shift, right? K represents a vertical shift. In the sense of, if there is no shifting, every circle is centered at 0, 0. So as soon as you have x minus h, ooh, it just got shifted right or left, depending on the sign. If there's a k, ooh, it got shifted up or down, y minus something, y minus k. Just a quick heads up. What's r? That's an easy one, right? R is the radius. But, quick heads up, remember, whatever number you see, you have to square root for the radius. And technically, with rectangular coordinates with x's and y's, radii will always be positive. Mathematically, technically, take a square root, you could think plus or minus, but just geometrically, real world, measuring radii will always say they're positive numbers. Now, what is unique about this example? It says, hey, find the equation of the circle. All right, cool. It doesn't give me a radius. What does it give me? 2 points. 2 points. And 1 point is the center. So I can plug in HK right away, right? So I can plug in, all right, x minus, what's the x coordinate of the center? -1. So x minus -1 will be x plus 1, right? If I can get my plus in there. The y coordinate of the center is 2. Struggle, I'm so close. X plus 1 quantity squared plus y minus 2 quantity squared equals r squared. Struggle, I see the r. Do you see the r? I see it, but what is it? I'm hearing distance, that's great. My visual ones, you might be like, hey, it's a Pythagorean theorem, and it is. My formulaic ones are like, there's that formula I have to plug it into. Well, you can if you like it. I wouldn't necessarily say you have to. If we were using Pythagorean theorem, how would we think about this?
You would make another radius, wouldn't you? Yeah.
Make a radius per se. I could go this way. And what would be the one leg of the triangle, the bottom one?
It would be 5, 4.
1, 2, 3, 4. And what would be this one?
2.
Mm-hmm. Now, can we find that by doing subtracting, like x2 minus x1 and y2 minus y1? Yeah. Or we could just look at it like Pythagorean and say, okay, r squared is equal to 4 squared plus 2 squared. 4 squared is 16, 2 squared is 4. R squared is equal to 20. It's not pretty, it's not gorgeous, but we can go ahead and plug it in because our formula doesn't really need R. It needs R squared. Dun, 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 dun. Does that make sense? If you were to find R, what would he have been if we had kept going and then plugged it back in and squared it again? Square root of 20. Which we wouldn't have left it like that, just to make sure we're reviewing. What would square root of 20 have simplified to?
4 square root of 5, 2 square root of 5.
2 square root of 5. Square root 4, square root 5, square root of 4 is 2. 2 root 5. But do you guys see why we didn't have to do all that work? We needed R squared. We had R squared. Oh, just plug it in. Plug it in. So, was this a little bit more complicated of an example for finding equation of a circle? Yes. Were all of the homework ones this hard?
No.
I don't think so. Maybe. Speaking of homework, color pen or colored pencil. Not black, not gray, not yellow, not highlighter. Spiral open to homework number 2. I'll get back to teaching in just a second. Alright, section 1-3. Linear equations. Can you guys tell we're starting at the beginning? We talked about graphs in general in section 2. Now we're like lines. Oh, lines. We got this, right? Okay. What are some typical ways of showing equations of lines? Y equals mx plus b. It's the one that's most familiar. Sadly, it's not the one that's most useful. There's a better one. It's harder to remember. Technically, there is one more. Do you guys know the last one? I don't like it. It's my least favorite. It's like from Algebra 1.
Oh, yeah, that one.
Let's just... Every now and then you'll see a line like that. It's not either of our favorites. But we do have our slope-intercept form. You guys can still write in cursive, right? You're not the ones that stopped learning in school. Really? Okay. Point slope is, to be honest, and getting ready for calculus, the most useful one. But we definitely will still refer to slope-intercept. Typically, and I'm going to actually skip down here for a second. Typically for slope, we do have the good old-fashioned rise over run formula, which can be shown as delta y over delta x. You guys remember from your graphing calculator handbooks, what's that Greek letter delta stand for in this context? Change in. Which change in difference of, hey, that's actually a math term. That's subtraction, isn't it? Why, yes, indeed it is. This will work out great, but there are a couple special slopes that can occur. One special slope would be m equals 0. Another special slope would be m is undefined. And technically, just to be spiffy, we're going to say infinite. We'll get ready for calculus. We'll state it like it really is. It is undefined, but it's undefined because it's infinite. That's interesting. What kind of line has a 0 slope? A slope of 0? If you have no incline, it has a slope of 0, right? If you have an incline, you're going to go down that one pretty well, right? You're going to go down that one really well, and you're going to die on that one. So anyway, this one, horizontal line. And if you guys remember, what axis has horizontal tick marks? Y equals a constant. Y equals, I could have stated A or B or C. But for sake of argument, I'll just say Y equals a number. Any line of the form y equals a constant, no x variables whatsoever, is going to be horizontal with a slope of 0. What kind of lines have undefined or infinite slopes? Vertical ones, which are of the form. So some of these things we've already introduced, but since this is the linear section. And two-dimensionally, can you have lines in the third dimension?
Yes.
It's going to be that whole x and y and z popping out thing, but we're not dealing with those. Those will look a little different. Quick writers. Awesome.
What do you mean with m is undefined? You just mean like y equals a number without the x?
Nope, that's this one. See? Y equals 2, y equals 3. That's m equals 0. Because think of it, it'd be like, what's another way of writing the horizontal line? This one makes the most sense. Right?
Yeah.
Because it'd be like 0x, x is gone, y equals number, m is 0. This one, there's not even a y. Because if you think about an x equals line, how many heights does an x equal line have? All the heights.
Oh.
But only one x value. So x determines the line, not the y's. Infinite slope, I'll describe that more. Parallel and perpendicular. Two huge clue words. Parallel, what does it mean? In reference to slope. It does never touch, two lines that never touch, but they could be actually skew lines. Same slope. Same slope and different intercepts would probably be a good way of putting it, because then it'd be in two different locations. Otherwise, if they had the same intercept, it'd be the same line. It's kind of boring, and yet, to be honest, still kind of possible. Same slopes you could set, for instance, the slope of one of the lines equal to the slope of the other line. If it gave you the hint it's parallel, you can make that deduction. Perpendicular. Remember the technical way of describing the slopes? Opposite reciprocal. Two parts to it. Yes, you have to flip, but you also have to have the opposite sign. Opposite means if one's the negative, the other one's a positive. Reciprocal means if one's 1/2, the other is 2. If one is 2, the other is 1/2. And technically perpendicular lines, opposite reciprocal slopes, they meet at 90 degrees, right? So seeing the example down at the bottom, let's have fun with him a little bit, huh? Let's play around algebraically. Checking out the directions, they do say find the slope-intercept form of. So we want it finally in y equals mx plus b. But what do we know? We're relating it to that one. Technically, what form is that? We didn't really label it. Do you remember what it's called though?
Standard.
Standard. Not a fun standard, but it is standard. But do we like standard form?
No.
So let's rewrite this puppy in slope-intercept form. What would I get? Any mental mathers out there? If not, do it step by step and get it right. But for sake of illustration and moving quickly, mental mathers? Y equals?
Y equals 2x plus 5 over 3.
You have the 5 over 3, right? Not negative. Y positive. Subtract the 2, divide by the negative 3, yeah? Subtract the 2x, divide by the negative 3. But if we divide by negative 3, the slope is a positive. The intercept is a negative, yeah?
Yeah.
Okay. So what slope am I comparing it to? 2/3. Okay, so how do I keep or make this new line going through the point 2, -1? How do I make it parallel? Keep the slope 2/3. Ooh, why do I have parentheses?
Because we gotta do point slope.
Point slope is the easiest way to go. Why is it y plus 1?
Because the negatives.
Y minus a negative. I'm plugging in the x1 and y1. I'm plugging in the coordinates of the point into point slope form. Now technically they want slope intercept, so how do I finish this puppy off? Distribute. If you're bad at fractions, there's no shame in that. We just got to get you better. If I have 2/3 times -2, hopefully we get it to negative. You need to think of that as 2 over 1, yeah? Then we have 4/3. We're almost done. We still have to solve for the y value. You need to subtract the 1. That's all well and good for this side. What's a whole lot better when we get over here? Make that 1 into 3 over 3. Then I can get y is equal to 2/3 x, negative 4/3 minus 3/3.
What formula was that again? For A?
Point slope.
Point slope.
We were using, oh, I passed it. Where you plug in a point, and then you plug in the m, and then you simplify.
Okay, and the M was.
We stole it from the other one. So we stole his 2/3 and just used it. And then we put in the x, we put in the y.
Okay.
Does that make sense?
The perpendicular one,
Mhm.
you're just gonna flip the positive to this one or to the top one.
Well, we still have to use our point, right?
Yeah.
So we still have our y plus 1. Nothing changes except for the slope. So I have to come back to my reference slope, 2/3, but I need it perpendicular now. So opposite means not positive, negative, and not 2/3, but 3 over 2. And then simplify, simplify. Which ends up, we have to distribute y plus 1 equals negative 3 halves x. Fraction, people. If you don't like them, it's okay. Power through. 2 is 2 over 1. The 2's will cancel. We'll end up with positive 3. Got the 1. How could you, if you were allowed to use your calculator, double check? You could graph them and make sure the parallel ones look parallel and don't intersect, and the perpendicular ones look perpendicular. Remember, your grapher is a little bit skewed. Now, pencils down, because whatever I do, you probably won't get to have written down. And remember, it's better to listen than to cram and have no clue what was said. Oh, that's nice. We're done. So, tonight, homework. What's done?
Slopes.
Oh my goodness, there are 2 pages, right? Sweet. Lines. Have your notes close. Some of you guys don't like point slope. That's okay. Just work on it tonight. We're able to, in these first few sections, work on the fundamentals, work on special lines. What did we not practice? y2 minus y1 over x2 minus x1. So some of you might need to practice that. We just didn't do an example because it's like you've seen it. And if you need, guys, how many pages were my notes? How many pages in the book? 1, 2, 3, 4, 5, 6, 7, 8, 9. Are there lots of examples if you need it? Tonight's homework. Attempt it fully. And if there's something you're like, it's not in our notes, where do I want you to go look? Okay, let's practice using our book tonight. Sound good? We're going to practice using our book. What was the one problem from yesterday's homework that we didn't get to go over? Number 85. We're not going to solve the whole thing, but let's talk through it. Just verbally. We're not even going to write anything on the board because we have, what, a minute? And a half?
No, seconds.
Oh, we have 3 seconds. NFL playing field. It's a rectangle. That's a good start. We'll finish it tomorrow. Bye, guys.
Oh my goodness.
Football people probably had a 1.